cutting flutes to trace complex boundaries, while face mills distribute cutting forces across multiple wide-set inserts to clear flat planes efficiently. Standard cylindrical cutters are excellent for bulk removal, but they hit engineering limitations when a part requires specific complex undercuts or perfect external curves. That is where you apply a corner rounding milling cutter. Notice how the cutting teeth are curved inward along the circumference to form a strict quarter circle contour. This inverted geometry is the only efficient way to mass-produce perfectly smooth, convex radiuses along the outer edges of a part without relying on slow, complex 3D contouring. Internal specialized geometry requires specialized tools, like the T-slot cutter. Mounted on a straight or taper shank, the T-slot cutter features profile-sharpened, staggered side teeth. As it moves through a pre-milled channel, these teeth carve out the wide base of the inverted T-shape. The most common industrial application for these precise slots is manufacturing the heavy steel work tables of the CNC machine tools themselves. While standard mills handle the bulk rough shaping, achieving final part compliance often demands specialized inverse geometry cutters to execute exact edge and slot tolerances. Beyond shaping edges and flat planes, the most common feature in any CNC operation is hole making. Drilling a precise hole requires a strict operational sequence. You rarely start with a standard drill bit. Instead, you begin with highly rigid, short-fluted tools, the spot drill and the center drill. The spot drill has a singular purpose, to punch a precise, shallow dimple into the surface. This creates a physical guide point that prevents the longer, more flexible drill bits from walking off target as they enter the metal. The center drill operates differently. It has a two-part tip that cuts a small pilot hole, followed by a larger 60-degree countersink, specifically intended to hold the ends of stock material inside a lathe. Once the surface is accurately spotted, the high-volume excavation begins using the standard twist drill. The cutting action of a twist drill happens entirely at the tip. Most standard twist drills feature a conical cutting point engineered with a precise 118-degree angle. The long helical fluter to evacuate the metallic chips rapidly up and out of the bore. Because of this specialized cutting tip and efficient chip clearance, twist drills offer an outstanding material removal rate, plunging into the workpiece much faster than an equivalent-sized end mill. Precision hole making is sequential. Absolute locational accuracy requires a rigid, shallow spot before deep volumetric excavation can occur. Drilling removes the bulk of the material, but finishing the hole requires